Welcome back. The topic that we're going to discuss is effect of substituents in aromatic substitutions. Now, we learned 5 aromatic substitutions, right? And in each of those cases, I told you what it is that we're actually adding to the ring. Now, I specifically mentioned in those cases, the ring was uncluttered, so that electrophile that we're adding can just go about anywhere as it wishes because it's identical. So it could have really attached itself to any of the 6 corners of the ring. What if that's not the case? What if we have at least 1 or 2 or 3 substituents on the ring? Then where it goes is guided in a specific channel. So there are 3 primary positions with respect to a substituent. Okay, let me keep this as simple as possible. So let's say this is the benzene ring, and say you have a generic substituent X. Okay, with respect to the X, these are the ortho positions, ortho as in O, and these are the meta positions with respect to the X. Okay, ortho, meta, and with respect to the X, this is the para. So this is meta, ortho, and para. So you have 2 ortho positions in a benzene ring with respect to this substituent. Now you could ask, hey, what if you drew your substituent here? Well, if the X was here, then this is ortho. This is ortho as well. The next position, this is meta, and this is para. Okay, the 2 adjacent positions to a substituent is ortho. The next 2 adjacent positions is meta, and then the next 2 adjacent, there's only 1 position left after that, and that's para. Okay, that's the positions names, ortho, meta, and para, right? Now, depending on what the X is, where the incoming group goes is what we were really going to focus in this video. Okay, now there's really, 2 major topics here: ortho, para directors, and meta directors. Okay, say if your X is one of these groups, okay, amino, hydroxy, amide, alkyl. Now, if one of these is present as X, then the incoming group can only go to an ortho or para position. Okay, you will understand this better when we do an example. Okay, if this is the group that's already, if one of this group is already sitting on the ring, then the incoming group electrophile can only be added to an ortho or para position. Okay, that means you'll have an ortho product and a para product. Okay, if one of these group is present as in place of an X, then again the incoming group can only go to an ortho or para position. Okay, and say if one of this group is present, whether it's an aldehyde, ester, acid, ketone, or one of this group is present already on the ring, then the incoming electrophile can only go to the meta position. Okay, now there's also another thing which we will learn later in this particular sequences: competition between, say you have 2 substituents. Okay, then you have to determine whether the 2 substituents are activating or deactivating, or if they're both activating, then which one is better activating out of the 2. Okay, let's say I'm just going to make this up completely. Okay, say I have 2 of these. Say I have NH2 and I also have a Cl. Okay, this is the 2, and I'm reacting it with, say, I'm doing a halogenation or nitration or one of the 2. The ring already has 2 substituents, right? So one of which only one can dominate. Okay, now if you notice, NH2 is under the activating column, the Cl is under the deactivating column. Whichever group is activating wins the race. So NH2 is the one that can actually dominate. So with respect to NH2, this is the ortho positions, right? And because it's an ortho-para director, right? It's under the ortho-para, which means you can have, technically, there is something else we learn is the incoming electrophile can go here, or here, or here. Please do not put in all three in one. Write it 3 separate times and add it each time. But then we will learn something called steric hindrance. And I don't want to say that in this context because I want to keep the video time shorter. There is something called steric effect, that is overcrowding. Okay, we will talk about that as we get there. So the idea here is if you have 2 substituents, then you have to determine which one is more activating out of the 2, and then that will determine the ortho and the para positions. Means you have to write ortho and para or meta with respect to that particular group that's winning the race. All right, let's do a quick example on this topic. Okay, so we have a BR, right? It's a deactivating group, but it's the only group. So the deactivating or activating doesn't matter at this point. It's an ortho-para director. If you go to the chart, BR is across ortho-para. It means with respect to the BR, right? For now, I'm just going to do this once so that you get used to it. With respect to the BR, this is an ortho position, this is an ortho position, and this is a para position. Please don't write all of this in one product. That's not correct, okay? You have to do it multiple times. These 2 ortho positions are identical, so you do not have to do it twice, just do once. So that means you can technically have 2 products, 3, but 2 of them are identical, so that makes the 2 as 1. So we know that when this is the reactant, when these are the reactants, we're adding a NO2 plus as an electrophile, right? But we're really only adding NO2 as a product in the very end. So we can have a NO2 here or NO2 here, right? The NO2 plus could have gone to this position or this position. Writing it on the other side is same as this one. Now there's a rule that says if groups are further apart, they're more stable than when they're right next to each other. So this would be the major product because the 2 groups are further apart. This would be the minor product. Okay, same thing here. NH2 is a activating group, but at this point that is not a problem, but it is an ortho-para director. So this is an ortho position, this is an ortho position, and this is the para position with respect to the NH2. Now we know with respect to this, if these are the reactants, we're adding a Br plus as the electrophile to the ring, but then when the product is achieved, we've only added just the Br. So that means we can have 2 separate products here. So we can have one of the ortho products, which is just adding a Br in this position, or we can add the Br in this position. As with the previous case, if groups are further apart, they're much more stable. So this would be the major product. This would be the minor product. Okay, and I want you to let's do one more, and then I want you to practice these. So this is again ortho-para director. So this is ortho position, this is ortho position, and this is para position. I didn't mention this, but just like Br2 Fe Br3, Cl2 Fe Cl3 will generate Cl plus. Again, when you're finished doing, you will only add Cl to the ring. So that means you will technically add 1 Cl to the ortho position or 1 to the para position. Again, when groups are further apart, they tend to be much more stable. So this would be the major product, and this would be the minor product. Okay, I want you to practice this and also this. Okay, let me go back. This, I want you to practice these. Okay, I want you to practice these and show me the product. Well, in this case, I'm going to say R, let's say CH3COCl, AlCl3. You have to use the chart to determine the ortho, whether it's ortho, para, or meta. And then this is a meta director, so let me do one of these. So that means we know we're adding a CH3CO plus to the ring, right? With respect to the NO2, this is a meta position. This is a meta position. So we're only adding, just do it once, okay? You don't need to do it twice because it's essentially the same product. So we're adding a CH3CO to the ring, right? But keep in mind, we did not add it as CH3CO, we added it as COCH3, and that's it. So practice this, okay? Practice that. I've already done this for you. And then practice these as well. Okay? Now, all of these, if you notice, we've done only one substituent, okay? The next set of videos will focus on competing substituents. That means we'll have two, and then we'll do the same electrophilic substitution reaction. Does that make sense? Again, this is a very, very easy topic. Once you really get used to the idea of knowing what to do, it just is very easy. All right? So I'll see you back with the competition. So I want you to practice these two. This one. Sorry, these two. This one, and then this one. Okay, the ones I did not complete. All right, so stay tuned for when we do competition.